This video covers topic 16.4 over exponential functions, day 4. So the first thing we're given is a graph, a table, and an equation, and they ask us to determine some of the following. So the first is asking for the domain and the range of this function. So when we look at the graph, we know that our domain for all exponential functions is all reals, and the range is from our y's. Now remember, we have this thing called an asymptote. The asymptote is where your function gets very, very, very close but does not touch. So my range is everything greater than 0. It is not equal to 0 because that's where my asymptote is. This function, even though we read graphs from left to right, it's easier to explain as though you're walking this function and this function hits a wall and it no longer can go there, and this wall is at 0. So your function gets really, really, really close to 0 but will never equal 0. Your y-intercept is the value of 0, 3, because that is where it crosses the y-axis. Your initial value is the same as your y-intercept, which is also at 3. Now they are asking us if this model is growing or decaying. So if we look, we have a couple different things going on. Now this graph here does not match this equation. I know it doesn't match the equation because my initial value on the equation is 1/2, but on the graph it's 3. So both my graph and my equation are growing, and my table is decaying. Okay, so we're just going to look at the graph for this piece, for all of it basically. And this exponential model displays a growth because the graph grows from left to right. So my graph starts low on the left and ends up high on the right, so therefore it is growth because my graph is growing. So for this first example, we have two graphs here, and they ask us what we notice about the graphs. Immediately, we can kind of see that one is growing and one is decaying, so we're going to put that under their different. One grows and one decays. And just for our reference, I'm going to label growth and decay on there so we know which one is which. So they are different because one is growing and one is decaying. They are similar because they both have lots of dots. They both have a line. And somebody noticed in one of my classes that my x values are both time. Now they're different amounts of time, but they are both relating to time. So what do we notice about these graphs? What's different than the ones we've seen before? So some people said that they noticed that they have a line going through them. And that's what's different for us. These graphs have what's called a trend line, meaning all of these dots are not perfectly on the line, but there is a general upward growth trend. Same thing for the graph on the right. The line does not go exactly through every single point, but these points have a general decaying trend. So we can see a type of trend line that's going through them, which is why these are different than the ones we've looked at so far. So if we are given information, we can come up with our own trend lines, and here's how we're going to do it. In example 2, we are talking about a bacteria population being grown, and they ask us to create a table, excuse me, they asked me to create a table and describe the population in words. So the first thing I'm going to do is fill in this table. For day 0, there is 1 bacteria. Day 1 has 2. Day 2 has 4. Day 3 has 8. And day 4 is going to have 16. So in words, what I'm noticing is that these are doubling every time. So each dish has double what the one before it had. Now we're going to follow these steps right here. This is a little star, not an A. We're going to follow these steps to find the exponential equation for this population. So I'm going to follow the steps that they've given me, and what I'm going to do is click Stat, Enter, and I'm going to enter all of the data that I have. So my X's go in L1, and my Y's, the number of bacteria, go in L2. If you need to do this, you can pause the video right now to put these in. From here, I follow my second steps, which is to click Stat, scroll right to calc. And because we know this is an exponential function, or an exponential equation because they told us that in the problem, I scroll all the way down to 0, which is an exponential regression. I click enter and scroll all the way, click enter as many times as it takes until you get here. So my equation is going to be y equals my a value, which is 1, times b, which is 2, raised to the x. So just like we can use a calculator to figure out a table in a linear capacity, we can do that in an exponential capacity as well. For example 3, Michelle is depositing $300 into an account that earns 7% annually. And we've reminded you here that with percents, you have to Beyonce them to the left 2 times so that you can find your decimal. They then ask us to create a table of values and write an equation to represent the situation. Well, in order to write an equation, I need an initial starting value and a rate. Both of those things have been given to me, so I can go ahead and write my equation and use my equation to fill in the table. So, my equation is going to be $300 starting, 1 plus my decimal of 0.07, raised to the x, or raised to the t. So I can plug this equation into y equals now that I have my equation, I can go second table and come up with some points. So I'm going to double check. 0, 300 is already there. So when x is 1, my money is 321. When x is 2, my money is 343. 3 is 268. I'm sorry, 368. So we're growing. 4 is 393. And 5 is 421. Okay? Now, in the bottom, when they give you a value, what they're asking you to do is replace this with the equation. So we've already written the equation, but on your assignment, there's one where you would not have the equation already. So let me show you what you would do. If you have the table, or you can figure out the table in a little bit easier capacity than this one, then we can plug all of our numbers back into StatEdit. Stat, calc, scroll down to 0, enter as many times as it takes, and this is what they're asking me for. So 299.9 basically rounds to 300. My b value is 1.07 raised to the x. Now if you notice, this is the same thing we had written here. 300 was my starting, 1 plus 0.07 is 1.07, so that's my b value. So if you can write the equation, all they're asking you to do is rewrite it here. If you're given info and you can figure out the table, then you need to put the table in StatEdit and figure out your equation. And I apologize, this would be to the t because my variable is a t. Okay. Now the question, how much will she have in 15 years? We plug that equation, which we've already done, into y equals. We go to the table. 15 years is an x value or a t value of 15. And at 15, she will have 827.71 cents, and we round because it is money. Now they ask me if this is discrete or continuous. This would be discrete because she's getting paid annually. She gets paid 300, then she is 321. She will never have anything in between because there's no way to go in between that money if she's only getting paid once a year. So because there are no in-between y values, that would make sense. She has this amount of money, then this, then this, then this, and she's skipping to these amounts every time. It will be discrete. Okay, so because she's getting paid once a year, she would not have in-betweens in her account. She gets paid one time a year every time. So if you look in January, if you look in December, she's still going to have the same amount of money. The last problem is talking about an SUV, and Julie has already given us this equation. So they ask us for the car's initial or original value. So we can look at the table for the y-intercept, or we can look at the equation for the y-intercept. So her initial starting value is 32,000. Then they're asking over time, is this increasing or decreasing by what percent? So if we look at the table, we can see it's decreasing, and it's going to decrease by 85%. Now we're going to use her equation to predict the value in 10 years. So I'm going to go back to my calculator. And y equals, I'm going to put in Julie's equation. So 32 parentheses 0.85 raised to the x. And then I'm looking for 10 years. So that would be 6,300 because 6.3. But it is in the thousands.